Now we want to want to differentiate the log function, and we want to prove the derivative first. So what we want to prove is this result: natural derivative of natural log of x is equal to 1 on x, or x to the power of minus 1. Now, if you remember, you couldn't integrate x to the power of minus 1, because if you add 1 to the power and then divide by the new power, which would be 0, you got it undefined. So the integral of 1 on x is actually log of x, and vice versa. Derivative of log of x is 1 on x. Here's the proof. So if we start with y is equal to natural log of x. So to do this proof, we change it around to an exponential. So we use our definition of our logarithm to put it in that form. So now dy dx is equal to e to the y, because we derive x with respect to y. If we swap dx and dy around, so we take the reciprocal there, we take the reciprocal on the right hand side as well. So that becomes 1 over e to the power of y. And e to the power of y, as we said before, we defined it as x. So dy dx is equal to 1 over x. So there's a derivative of y with respect to x, and there's our derivative. So there's the proof. It's a nice little proof, but what we want is make sure you understand that you get that result. And in particular, you're going to get this result more of the time, because natural log of x is pretty generic. So more we're going to get is natural log of some function, and using our chain rule, that's going to give us a derivative of the function over the function. So every time you get the derivative of a natural log of a function, natural log goes, and it's a derivative of the function over the function. Remember this rule, highlight it, and you need to remember this one all the time.